Welcome to the video course on Verilog HDL. I am Dr. M.C. Hanumantaraju, Professor at the Department of Electronics and Communication Engineering, BMS Institute of Technology and Management, Bengaluru. The Verilog HDL course is a course offered for the Bachelor of Engineering students of Electronics and Communication branch under Choice-Based Credit System CBCS. The course is offered for the 4th semester students, and the title of the course is Verilog HDL, and it has a credit of 3. The syllabus for the course is effective from the academic year 2021-22. The course syllabus is as follows. We'll start with the course code, which is 21EC46, that is the course code. Continuous internal evaluation marks is 50. Teaching hours per week with the nomenclature LTP, lecture, tutorial, practical, is 300. That means the lecture hours is 3 per week. The semester end examination marks, SE marks, is 50. The total number of lecture hours required for the completion of the course is 40, and the examination hours is 3. Now let us focus on the course objectives. From the faculty or course coordinator perspective, the course objectives are defined as follows. This course will enable students to understand the structure of hardware description language programming. The course will help us to apply the different styles of description such as data flow, gate level, and behavior level of abstractions on digital systems. Finally, the course will enable the students to learn design aspects of various digital subsystems using Verilog HDL. Now let us focus in depth about each module. The entire course is divided into 5 modules. The module 1 focuses on Introduction to Verilog HDL. In this introductory chapter, we have 4 sections. The introduction section, where we will cover Introduction to Hardware Description Language, significance and scope of Verilog in the present scenario, the industrial applications of Verilog HDL, research and innovations related to the Verilog HDL. The HDL course and its impact on the societal problems will be discussed as a last topic. The next section covers overview of digital design with Verilog HDL. Specifically here, we discuss topics such as emergence of hardware description languages. Next, we'll focus on typical design flow. Here, we will discuss ASIC design flow and FPGA design flow. And with an example, we will illustrate what are the design steps to be followed for FPGA design and ASIC design. Finally, under section 2, we end up with trends in hardware description language. The third section of module 1 covers hierarchical modeling concepts. Namely, here we discuss design methodologies. In design methodologies, we will cover both top-down and bottom-up approaches with an example. The example specific here is 4-bit ripple carry counter. And also we'll discuss structure of the Verilog HDL, including modules and module instances. And also we will cover parts of a simulation, design block, and stimulus block. The fourth section of module 1 covers basic concepts. In this section, we will cover syntax and semantics of the Verilog HDL, which includes lexical conventions, data types, wherein which we will cover various types of operators, systems tasks to operate the system, simulation various tasks we'll cover here. Lastly, the compiler directives. To control the simulation, various directives, compiler directives are essential. Those compiler directives will cover in the last topic of basic concepts. Overall, the module 1 requires 8 hours. Here, we will follow text 1. Okay, text 1 to cover this entire all the topics. In module 2, we'll discuss two different types of descriptions: data flow modeling and behavioral modeling. The data flow modeling, here we need to refer to the text 1, whereas for behavioral modeling, the students need to refer text 2. Both data flow modeling and behavioral modeling together, this chapter, this module 2 can be named as modeling of digital systems. Modeling of digital systems. In this module, we will cover data flow modeling and behavioral modeling. Now, with reference to the section data flow modeling, the continuous assignments, delay specifications, expressions, operands, and operator types are included in this section. Whereas in behavioral modeling, we'll discuss process model and the syntaxes such as if then else, loops, multi-way branching, functions, and tasks are covered in behavioral modeling. Now let us move to the module 3. Module 3 describes concurrent processes. That's the title of the module 3. Now, what do we mean by concurrent processes? Concurrent processes is nothing but multiple instructions are executed simultaneously for better performance. Here, let us try to understand how Verilog simulator or compiler executes multiple statements similar to that of hardware, and we'll discuss various topics under this concurrent process. Basically, this chapter is explained, keeping in mind the system performance. The first topic under this section starts with concurrent processes. We'll discuss different types of concurrent processes, events, the wait statement, a concurrent process example. Also, we'll discuss a simple pipeline processor. This is another method to increase the system performance. Intra-assignment control and timing events, procedural continuous assignment statements, sequential and parallel blocks will be discussed under concurrent processes section. The module 3 in turn requires 8 hours. The textbook required for this is text 2. Now moving on to the module 4. In module 4, we reserve for logic synthesis using Verilog HDL. The logic synthesis is an important step in the design flow. So we know that logic synthesis means here the HDL description in high level form is converted into the optimized gate level netlist. So we'll discuss how to convert HDL constructs into gate level netlist in this chapter. So the module 4, the title of the module 4 is logic synthesis with Verilog HDL. Here we'll try to understand what do we mean by logic synthesis, Verilog HDL synthesis particularly, interpretation of Verilog constructs, synthesis design flow, and we'll discuss a couple of examples. Also, we'll cover verification of the gate level netlist, modeling tips for logic synthesis. These are the topics which are covered under logic synthesis. The textbook required here is text 1. And this requires time of about 8 hours. The last module of this course is module 5, where we reserve this module 5 for SOC verification. SOC stands for System on Chip. SOC means a system on chip, is nothing but it is a combination of several computer peripherals in a single integrated circuit. So the word SOC means its complete system is on single integrated circuit. Here in this section, we will see how to verify the SOC, specifically verification technology options, verification methodology, and how to create test bench migrations. And there are a couple of languages which we'll discuss called as verification languages, verification of intellectual property reuse, verification approaches, and lastly, verification and device test. So these are the topics covered under system on chip verification. With that, so we will conclude with the summary of the course. So this Verilog HDL course covers starting from the introduction of Verilog HDL to the verification. Now let us focus on what are the takeaways from this course. So that's called as course outcomes. The students will be able to attain 4 outcomes which are labeled as CO1, course outcome 1, course outcome 2, 3, and 4 respectively. Now let us try to understand what is CO1. Course outcome 1, here the students will be able to apply the knowledge of design methodologies to various digital circuits. As a second course outcome, the students will be able to analyze various levels of abstractions. We mentioned already 3 levels of abstractions. Those abstractions on digital system using Verilog HDL will be able to cover in CO2. Course outcome 3, the students will be able to interpret the given case study material related to design and demonstration of a digital subsystem, that is CO3. Lastly, course outcome 4, here the students will be able to write Verilog HDL code for circuit level modeling using Verilog HDL and perform in a group and make a presentation in a group. So whenever the student makes an effective presentation, so we say that CO4 is attained. Now let us focus on the question paper pattern. The entire assessment of Verilog HDL course is divided into 2 segments, namely the CIE, which is continuous internal evaluation, and SCE, semester end examination. The semester end examination will be conducted for 100 marks. The question paper will be set for 100 marks with the duration of 3 hours. The marks scored will be proportionally scaled down to 50 marks. The question paper will have totally 10 questions and each question is set for 20 marks. There will be 2 questions from each module. Each of the 2 questions under a module will have 3 subsections. Here is a small correction. Each question is set for 16 marks. The reason is there will be 20 multiple choice questions. Therefore, the 16 marks into 5 modules, which will be equivalent to the 80 marks, 16 into 5. From each module, we will cover 16 marks and totally 5 modules are there. So totally it is 80 marks. And there will be 20 multiple choice questions, MCQs, which carries 1 mark each. Okay. So together 20 multiple choice questions, 20 marks plus 80 marks will be 100 marks. There will be 2 questions from each module. Each of the 2 questions under a module will have 3 subsections, as I already mentioned, and there will be a mix of topics under each module. The students need to answer 5 full questions. Selecting 1 full question from each module is compulsory. Also, the 20 multiple choice question is also compulsory for this course. Now let us move on to the continuous internal evaluation. The continuous internal evaluation includes 3 unit tests of 20 marks each for the duration of 1 hour, and 2 assignments of 10 marks each, 2 alternate assessment tools for 20 marks, that's for 1 hour. Now, the total continuous internal evaluation includes sum of 3 tests, which is 20, 20, 20, that is 60 marks. This is 3 tests, 20 plus 20 plus 20, which is 60 marks. 2 assignments, 10 marks each, plus there will be 2 assignments, 10 marks each, which contributes 20 marks. 2 alternate assessments for 20 marks, that's again plus 20 for 2 alternate assessments, which will sum up to 100 marks. Now this 100 marks will be scaled down to 50 marks. Now the ratio between CIE to SCE, CIE to SCE is 50 is to 50. Okay. This is the marks pattern for the final assessment. Now let us move on to the textbooks required for this course. Totally 3 textbooks are required, as you are labeling as text 1, text 2, text 3. Okay. Text 1 is authored by Samir Palnitkar. The title of the book is Verilog HDL, A Guide to Digital Design and Synthesis. Second edition, Pearson Publishers, year is 2003. The second textbook required for the course is authored by Donald D. Thomas, Philip R. Murby. The title of the book is The Verilog Hardware Description Language, 5th edition, Springer Science and Business Media. The third textbook required for the course is authored by Prakash Rashinkar, Peter Patterson, Lena Singh. The title of the book is System on a Chip, Verification Methodology and Techniques. Cadence Design Systems, USA, Clover Academic Publishers, year is 2001. The students can also refer few references which we have mentioned here for additional information about the course. The first reference is Stephen Brown and Zong Urancic author textbook called Fundamentals of Digital Logic with Verilog Design, 2nd edition, McGrail 2008. The second reference book is Peter J. Ashenden. Title of the book is Digital Design and Embedded System Approach Using Verilog, 2nd edition, Elsewhere 2008. With this, we have come to an end of the syllabus introduction. So, in the next class, we'll be covering with Module 1, the first topic of Module 1. So, keep waiting for the upcoming lectures. Thank you.